Space is infinite. We are surrounded by a never-ending sea of planets, stars, and galaxies that extend out
for a distance that is unfathomable to the human mind. This is what we are told, at least. But when we look out into space with our own eyes,
that blackness marks an edge, not the edge of our universe, but the end of our ability to perceive it.
The distance from where we are right now to the edge of the perceivable universe is about 46.5 billion light years.
A light year is simply the distance that light can travel in the time it takes for the Earth to orbit the Sun.
All light moves through space at a constant speed, and nothing can move through space faster than light. And for our sphere, that would be 93 billion years.
Inside that sphere is everything we have ever known.
Now here's where things start to get weird, because the edge that separates our cosmic bubble from the rest of the infinite universe is not black at all.
It's actually a wall of light.
but it's not light as we know it. This is ancient light, the first light that emerged from the...
Because it leads most people to believe that the universe began with an explosion.
It didn't, and we'll get to that in a little bit. But for now, at least, it doesn't really matter where the first light in the universe came from. At the very limits of our minuscule bubble, floating on an ocean of infinity. Now, the reason we see black when we look into space is because our eyes are just not capable.
We have to imagine light as a series of waves.
Like ripples on the surface of a pond. When a rock hits the water, it creates a ring of tight and clearly defined waves.
But that doesn't mean the impact of the rock ends at the last ripple. It continues on through the water, and you could easily measure its effect.
All you would need is an instrument sensitive enough to feel those small, lingering vibrations. This is why we build instruments like the James Webb Space Telescope, because it can see light in a way that the human eye cannot.
When those waves of light get stretched out past a certain point, they transition out of our visible spectrum and into a range known as infrared. You've probably heard of that before. Night vision goggles can pick up infrared light,
But only enough to see in the dark at relatively close distances.
The James Webb Space Telescope can see much deeper into the infrared spectrum.
It can look deep into our bubble, our observable universe, and it can see almost everything that has ever existed inside that bubble.
But James Webb still can't see the edge. In the end, beyond even the most distant
We are surrounded by microwaves.
Cepheid variable. Slower pulse equals brighter star.
Incredibly far away.
Gigantic system of stars.
Moving away.
The Doppler effect.
This is how we know there is light at the edge of the universe that is moving away from us at such an incredible light. This effect gives us a cosmic yardstick to measure the distance of every galaxy in the entire universe.
Cosmological constant. Anti-gravity cosmological constant. Force of expansion is not equal to gravity.
Dark energy.
Dark energy causes space to expand. Gravity causes objects to draw together.
No matter can move through space faster than light. Albert Einstein.
Expansion can move faster than light.
This force is so powerful that it will.
This expansion force will ultimately lead to a universal event known as the Big Rip.
This is how our universe is expected to end.
The universe isn't a place that started with an explosion. It's a journey.
A journey that will one day come to an end.
But that doesn't mean that it's just going to disappear and there will be nothing left.
After the big rip.
Forever. For millions of years, the universe has been a journey through an endlessly expanding space. But just like every good story, it must have an end. But that end is far, far in the future.